Example number 2 in the data analysis manipulation and linearization process is skid length versus speed of a car that has been traveling. So we have this data set here and we plot it. And if we look carefully, we see that it is not quite a linear relationship. So there are a number of relationships that we want to figure out. Does this data fit or match this mathematical relationship? And in order to do that, there's a test we can run. So looking carefully at some of the basic functions we've learned so far, and by we, I mean you guys in terms of your math class, we have linear, quadratic, cubic, square root, inverse, inverse squared, cosine, and sine. So looking at these are the ones we're going to be addressed in this course. The closest one here would probably be a square root function. So if we look at this, we have the speed on the y-axis and the skid length on the x-axis. So in a square root function, we have y is equal to radical x. So the square root of x. So what we're going to do is we're going to take what's plotted on the x-axis, in this case the length, and we are going to manipulate the data. So we take the square root of the length. And we're going to square root each term. So the square root of 25 is 5, 50 is 7.1, 100 is 10, the square root of 200 is 14.1, and the square root of 400 is 20. Then we will plot the square root of the length on the x-axis and the speed on the y-axis. And we will see, the test here is to see if that function turns out to be a linear function. So here this would be 5, 10, 15, 20, 25. All right, so in plotting the data, we see that we have a straight line. So this tells us that once we plot the manipulated data, the speed versus the square root of the length, all right, that this relationship is true. If this was not a straight line, we guessed wrong and we would have to go back and figure out, oh, it's not a square root function, but what function is it actually? So the next step here is to take a line of best fit to create a mathematical expression, and then to use that mathematical expression to make predictions from. So here in blue, we've drawn a line of best fit, and we've taken 2 points to find the slope of that. So the 2 points we took were 5 root, the square root of feet, and 23 miles an hour, and 20 the square root of feet, 92 miles per hour. So to find the slope, we're going to have 92 minus 23 miles per hour divided by 20 minus 5 square root of feet. This will give us 4.6 miles per hour divided by the square root of feet. So now what we're going to do with the slope is we will use our y equals mx plus b. And we have to be very careful here because we are not looking at x anymore, but we're looking at the square root of the length. So this would be speed is equal to 4.6 miles per hour divided by the square root of feet multiplied by the square root of the length. This would be the equation that we would end up using. So now the last question here in this example is, what is the distance of the skid mark if the speed of the car is 120 miles per hour? We'll substitute in 120 miles per hour. is equal to 4.6 miles per hour over the square root of feet times the square root of the length. So divide 120 by 4.6 and square both sides. We get the length is equal to 680 feet.